Okay, geometry class. This is the semester one final review. I'm going to go over probably about the first half of this. There's 2 parts to it, as you can see. I also really want you guys continuing to work on those proofs that I gave you on Friday. Anyway, so semester one final review. This is not a excuse not to do your work. If you just simply copy this down, sure, you'll get points for completing it, but you won't actually learn anything, and therefore you will end up failing the final. So that would be bad for all of you. Okay, so the first part of these, I was not your teacher, so I'm going to show you kind of how I did them, and if you guys know how to do them a different way, that's cool. So the first group is about the segment addition postulate. The segment addition postulate basically says that if you take a big stick and break it up into 2 little sticks, the length of the little sticks equals the length of the big sticks. Okay, I don't remember. So basically, that was not what I wanted to do. So here on number 1, the segment addition postulate states that if we add up the distance from C to D plus the distance from D to E, we're going to get this distance from C to E. Okay, makes sense, right? If we go right here and then right there, then it'll be the same as the whole way. Think about it, if I measure distance from here to Camp Verde and then from Camp Verde to Phoenix, that distance that I drove would be the same if I said the distance from here to Phoenix, right? So what we want to do is we want to go CD, which is 3, plus DE, which is negative 7, plus 2x, equals C to E, which is x plus 3. Combine like terms, that gives us negative 4 plus 2x equals x plus 3. Subtract x from both sides, put our variables together. We get negative 4 plus x equals 3. Add 4 to both sides, and we get x equals 7. Now, we're asked to find DE. So what we want to do is we go DE is negative 7 plus 2x. We're going to plug the 7 in there for the x. So we get negative 7 plus 2 times 7, which is 14. Negative 7 plus 14 equals positive 7. So DE equals positive 7. If that really straightforward way works for you, keep that. A different way that I've taught this that some people like is with colors. Yellow and blue make green, right? So if I know that I go the distance of the yellow plus the distance of the blue, I'm going to get the distance of the green. So RQ, that's my yellow, plus QP, that's my blue, equals RP, that's my green. So x plus 1 plus 2x minus 12 equals 10. Combine like terms, solve it algebraically, and I get x equals 7 again. So what I'm going to do is I'm going to plug that 7 back into QP, which is that 2x minus 12. Kenna, off. Kenna, McKenna, off. Kenna, no, don't ignore me, off. No, Kenna, do you want to go to bed? Off, come here. Kenna. Stubborn dog. Anyway, okay. So we go QP equals 2 times 7 minus 12, 14 minus 12, or 2. Okay. SU, finding SU, we need to go yellow plus blue equals green. So we know that the distance from S to T, 2x plus 4, plus the distance from T to U, 3, equals the distance from S to U, x plus 7. And we just solve it. We're going to combine our like terms. 2x plus 7 equals x plus 7. Subtract x from both sides. We get x plus 7 equals 7. Subtract 7, and we get x equals 0, which is fine. Now, SU, we're told, is x plus 7. That's the whole distance. So we go 0 plus 7 equals 7. And that's my answer. To find LJ, we set it up as LK plus KJ equals the distance from L to J. The 6's cancel out, so I have 2x equals 3x minus 7. I'm going to subtract 2x from both sides. I'm going to get 0 equals 3x minus 7. Add 7 to both sides, and I get x equals 7, which they apparently really like on this worksheet. Plug, now I'm looking for LJ, which is the whole length, 3x minus 7. So I'm going to go LJ equals 3 times 6, or 3 times 7, minus 7, 21 minus 7, or 14. Okay, on the bottom ones, the idea is the same, except now we're dealing with angles. Find the measure of the indicated angle. So the two small angles are going to add up to the big angle. Yellow and blue make green. So here we have EIH, that's my yellow angle, plus the measure of JIE, that's my blue angle, equals the measure of JIH, that's my big outside green angle. So then I plug the numbers in. X plus 51 plus x plus 55 equals 96. 2x plus 106 equals 96. Subtract 106 from both sides. I get 2x equals negative 10, or x equals negative 5. Now here's the thing. It's fine for x to equal negative 5. The angle itself can't be negative. Angles are always positive. So we're looking for EIH. EIH equals x plus 51. So we go, instead of x though, what we're going to do is we're going to plug in that negative 5. And we get the measure of angle EIH equals 46. Yay! Same idea for 6. RSF, or FSR rather, is yellow. TSR is blue. And TSF is blue, and TSR is green. So the measure of RSF plus the measure of TSF equals the measure of TSR. So my yellow, my FSR, 25x. My blue, TSR, 64, equals 41x. So I just need to subtract 25 from both sides. And I get 64 equals 16x. Divide by 16, and I get x equals 4. Now I'm asked to find TSR. That's my big outside angle. The measure of angle TSR, I'm told, is 41 times x. I know that x is 4, so I get 164 as my answer. Okay, slopes of the lines parallel and perpendicular. Wow, that was rough. To each given line. So all of these are in slope-intercept format. Y equals mx plus b. So I identify the slope, m, 3/4. Now I know that parallel slopes are identical. So anything parallel to that is going to be 3/4. Anything perpendicular to that is going to be the negative reciprocal. Remember how we do that is we flip it upside down, change the sign, and there we go. So for number 10, slope is negative 2. Parallel slope is also negative 2. Perpendicular slope, we're going to take that negative 2 over 1. Whenever we have a whole number, we just treat it like we just put it over 1 to get that fraction. Flip it upside down. So we have negative 1 over 2. Change the sign. So we have positive 1/2. Same thing for number 11. The slope here is negative 3. The parallel slope is negative 3 because parallel lines have the same slope. Perpendicular lines have slopes that are the negative reciprocal of each other. So we take the slope of this line, negative 3, flip it upside down, negative 1 over 3, and change the sign, 1/3. And that's any line that is perpendicular to that y equals negative 3x plus 1 line is going to have the slope of 1/3. Number 12, 3/5. Parallel, 3/5. Perpendicular, take that 3/5, flip it upside down, change the sign, and get negative 5/3. Okay, so these next 4 These all have to do with the exterior angle theorem. If you remember the exterior angle theorem, it states that the exterior angle of a triangle is equal to the sum of the remote interior angles, which means that outside angle is equal to the sum of the two inside angles. So we set up as 13x minus 12 equals, because in order to find, even though we know that r equals 8x minus 12, we need to find out what x equals. So we have 13x minus 12 equals 60 plus 8x minus 12. We're going to go 13x equals 8x plus 48, or 48 plus 8x. So I'm going to subtract 8x from both sides, and that's going to give me 5x minus 12 equals 48. Add 12 to both sides. 5x equals 60. Divide by 5, and we get x equals 12. So I know that the measure of r is 8 times x minus 12. So I'm going to plug that 12 right in. And I get 8 times, wrong button. 8 times 12 minus 12, or 96 minus 12, or the measure of r equals 84. Next up, um, 17. So the other one you do exactly like that. So 17, state if the two triangles are congruent. If they are, state how you know. Okay, how do we know if triangles are congruent? We have side, side, side. We have side, angle, side. We have angle, side, angle. And we have angle, angle, side. We also have hypotenuse leg, which we talked briefly about. So, how are these two triangles congruent? Well, we have two sides that are congruent, and we have an angle. But the problem here is when we look at this, we've got side, angle, side on one of them, but on this triangle right here, that angle isn't between the two sides. So no, we can't say if they're congruent. They might be. We just don't have enough information. Number 18, we know that because it's got vertical angles, those little bow tie angles, that those two angles are congruent. We then have two sides, side, angle, side, side, angle, side. We're good to go. So yes, side, angle, side. 19, notice that we have all three angles. So as we'll learn later in the year, these are similar. But that does not mean that they are congruent. We need a side. If we look back at the previous slide, we'll see that all of the hold on. We notice that all of the theorems for congruence we have sides involved in them. That's okay. They went to help take the dogs to the boarding place. What? I haven't checked the mail. So no, those are just three angles. There's no such thing as angle, angle, or angle, angle, angle congruency. As we'll learn later, they have to be similar, but that's kind of beyond what we're doing right now. No sides. Or I put no angles, I meant no sides. So let's fix that. Cross that out and put sides here. Okay. 25, value of x. So 20, 21, 22, 23, 24, those are all similar to what we just did. You need to use your knowledge on them. Remember, go back to this slide, and you have to have one of those 5 theorems in order to prove congruency. So 25, if you get stuck on them, I'll help you when I get back. So 25, I think that's the third time I've said 25. Fourth time now. So we're starting off with that 75. We know that these are isosceles triangles. So we know that if one of the bases is 75, the other base has to be 75. We know that all three angles have to add up to 180. 75 plus 75 is 150. 180 minus 150 is 30. We know that top angle is 90. So if the left side is 30, the right side has to be 60. This is also an isosceles triangle. So if one of the base angles is 60, the other base angle is 60. And if two of them are 60, well, the third one is 62. So x equals 60. 26. We know that if one base angle of an isosceles triangle is 63 degrees, the other base angle of the isosceles triangle is also 63 degrees. If one of a set of vertical angles is 63 degrees, so is the other one. Remember, whenever we have that x, that little bow tie looking thing in the middle, that gives us congruency. So if one's 63, the other one is 63 as well. 63 plus 63 is 126. So that means that missing angle is 180 degrees minus 126. Okay? And that gives us x equals 54 degrees. (27), we start with that 52. The other base is 52. We know those two together equal 90. So x equals 90 minus 52, or 38 degrees. 28 is a little bit different because now we have to solve for the angle and then plug the angle in to solve for x. But the same general idea. We start off with 71. We know the other base is 71. That means the two bases together are 142. We know that all three of the angles together in that triangle have to equal 180, which means that that top angle is 38. We know those two angles together have to equal 90. So measure of angle 2 is going to be 90 minus 38, or 52 degrees. So 52, right there, equals 5x minus 3. Add 3. Divide by 5. We get x equals 11. And that would be my final answer. 29, same general idea. 30, if one of the bases is 68, the other base is 68. We would then add two of them together. 68 plus 68 is 136. 180 minus 136 is 44. If one set of vertical angles is 44, so is the other one. If one set of base angles is 44, so is the other one. 44 and 44 is 88, which means that the measure of angle 2 is 180 minus 88, or 92 degrees. And then go plug that back in. 92 equals 9x minus plus 2. Subtract 2 from both sides. My brain was getting ahead of my mouth. 90 equals 9x. Divide by 9, and we get x equals 10. Okay, so again, these should be, once you've tried it, once you have worked through the problem, have an answer. If you're not sure, you can go back and check your work with what we're doing here. But it is not to just click through this and write down all the answers. You're not going to learn anything, and you'll fail your final. Okay, 31. So this is kind of a combination of what we've done before. It can either be triangle angle theorem, sum theorem, or exterior angle theorem. If one of the, so those two angles right there are vertical angles, which means that that inside one is x plus 80. So here then we have a exterior angle theorem problem. We know that x plus 65 plus x plus 80 equals 145. I got that backwards verbally, but wrote it out the same way. Combine like terms on the right, I get 145 equals 2x plus 145. Subtract 145 from both sides, and we get 0 equals 2x. Divide by 2, and we get x equals 0. Looking for the measure of angle A, so I plug that in. Measure of angle A equals x plus 65, or 0 plus 65, or, well, 65. 32. I know all three of those angles are going to add up to 180 degrees. So I go 6x plus 80 plus 4x equals 180 degrees. That gives me 10x plus 80 equals 180. Subtract 80 from both sides, I get 10x equals 100, or x equals 10. I'm asked to find the measure of angle A, which is 4x. Plug that 10 in, and I get 40. Okay, so graph the given line, 5 points. It's in slope-intercept format, so we plot the intercept, -3. Our slope is 8, which is up 8 over 1. Boom, boom, 5 points on the final. Write the equation of the line perpendicular to the given line, which goes through the point 3, -2. So, I know that the slope of this line is 8. So I know the perpendicular slope, flip it around, change the sign, is -1/8. I know a point it goes through, 3, -2. That's my x1, y1. So what I'm going to do now is I am going to put that into point slope form. Y minus y1 equals m times x minus x, or x minus x1. Y minus y1, y minus a -2 turns into y plus 2, equals -1/8 times x minus 3. And that's my second part. Now, it says there, find the point of the intersection between the two lines. I don't like that. I mean, it's frankly great, but it takes a lot of work, and it's not worth 5 points worth of time spent on it. So what I'm going to have you do on the final is just graph that second line and circle the point of intersection. So here we know it goes through the point 3, -2. Well, it's got a slope of -1/8. Now notice that if it's got a slope of -1/8, normally I go down 1 and over 8. Well, that would put me off the graph. So instead I can go up 1 and back 8 and end up there. Connect those dots, circle the point of intersection, and there we go. So these next ones, you really should have that chart I gave you of all of the angles. Remember, we labeled them 1, 2, 3, 4, 5, 6, 7, 8. And I had listed out all the different relationships, vertical angles, linear pairs, corresponding, alternate interior, same side interior, alternate exterior, and whether or not those were congruent or supplementary. So you should really have this. Here we have 3 and 5. If I look at my chart, I see 3 and 5 are alternate interior. That means they are congruent, so I'm going to set them equal to each other. 88 equals 4 plus 14x. Subtract 4. 84 equals 14x. Divide by 14, and I get x equals 6. Here, we're not asked to find the measure of the angle. That'd be too easy because we already have a point. Anyway, the next two, 1 and 2, linear pairs, supplementary. 9x plus 14 plus 10x plus 14 equals 180. That gives me 19x plus 28 equals 180. Subtract 28 from both sides, and I get 19x equals 152. Divide both sides by 19, and I get x equals 8. 36. We have angle 2 and angle 6. If I look on my chart, I see that those are corresponding, which means that they are congruent. So 10x equals 12 plus 9x. This is super easy. Subtract 9x, and lo and behold, I have x equals 12. Here I have 2 and 8, alternate exterior angles. Those are also congruent. So I go 11x plus 4 equals 10 plus 10x, and solve. You guys can solve it. So find the midpoint of the line segment with the given endpoints. I didn't do this with you guys. So hopefully you guys remember how to do this. Midpoint formula, distance formula, those are all really super duper important. There are no distance problems on here. I'll have to change that. So here we have x1, y1, x2, y2. Those are my 2 points, and I'm looking for the midpoint. I find the midpoint by going x1 plus x2 over 2 and y1 plus y2 over 2. So that gives me x, my midpoint for x, and my midpoint for y. So my midpoint for x is going to be -5 plus 2 over 2, and my midpoint for y is 7 minus 7 over 2. That gives me -3/2. I put 7, that's wrong. Just got used to seeing all those 7s. -3/2 and 0. I'll clean that up. There you go. 41, same idea. x1, y1, x2, y2. Average the x's. Average the y's. And write them as a point. Too much. So there, it would be -5 halves, -11 halves. So on these next one, we're given the midpoint and the endpoint. We're asked to find the other endpoint. So here, you need this formula. The second endpoint equals 2 times the midpoint minus the other endpoint. That works for x2 and y2. So, need to have that formula down. You need to be able to write it and plug it in. So here I'm looking for the x value of my second endpoint equals 2 times my x midpoint minus my x endpoint. So the x value of my other endpoint is 3. Now I need to find my y value. So it's going to be 2 times -9 minus 7, which gives me -18 minus 7, or -25. So my point that I get for my answer is 3 -25. So if I were to graph that, here's my one endpoint, here's my midpoint. They went, and then it makes sense where the other one would be. So we're going to do the same thing here. Our one endpoint. There's our midpoint. And you would fill that in to get the other midpoint. Same formula as the other one. Here, 44 through 47, all of these are triangle angle sum theorems. We know what each one of these adds up to. So 46 and 49, this is the last thing I'm going to do. If you guys get through all this, fantastic. Work on studying for your final, and I'll give you more work when I get back on Wednesday. But here it says, what additional information do we need for these? So 48 says angle, side angle. So we know that we have our angle right here with a side, and we need to know what additional information we need. Well, for angle, side angle, we need the side to be between the two angles. So we actually need this angle right here to be congruent to that angle right there. If we had that information, they'd be congruent. So we're going to say that the measure of angle GDC is equal to CDD. And that's it, and have a great day. I will see you guys later.